Hello, Algebra 2 students. This is lesson 51. Our objective is what are and how can I work with, quote, imaginary or complex numbers. And we'll be talking about what those are more in just a minute. Just for a second, remember that if we say the square root of something means what times itself is 4. So square root of 4 means what times itself is 4. We know that negative 2 times negative 2 gives you 4, and also 2 times 2 gives you 4. However, we reserve this to talk about just what we call the principal root. So we say the square root of 4 is 2. We call that the principal root, or the positive one. If we want to end up with negative 2, then we would say negative square root of 4, which would give us that negative 2. And if we want both the positive and the negative one, then we would say that plus or minus square root of 4, which is the negative square root of 4 and the square root of 4, both of them together. Okay? So we know all this with it being a positive number inside, but what about this? The square root of negative 4. What does that come out to be? Well, we know that 2 times 2 is 4, not negative 4, so that wouldn't work. And we also know that negative 2 times negative 2 is 4, again, not negative 4, so that wouldn't work. And thought bubble over here, we can't say negative 2 times 2, which would give me negative 4, because both of those have to be the same. So then, what do? Well, let's remember this. Remember that if we say the square root of m times the square root of n is equal to the square root of m times n, well, this can also go this direction as well. So I can write the square root of negative 4 as negative 1 times 4, which is the square root of negative 1 times the square root of 4. Well, that comes out to be, well, the square root of negative 1 times 2. Okay? That same thing holds true for, say, the square root of negative 9. I could pull that negative 1 part out, or with the square root of 13, I can pull that negative 1 part out. So we notice that kind of all of these that we couldn't solve before have that one thing in common. And that one thing in common we call the imaginary unit. Now, it's kind of unfortunate that we call it the imaginary unit because really, if you think about it, all numbers are imaginary. It's just a concept that we put with things to be able to count them. Okay, they're just a concept. So really all numbers are imaginary, but we call these numbers imaginary simply because we can't write them on a number line. The numbers we've worked with so far, which are real numbers, which are like positive and negatives and fractions and decimals, even things like, I don't know, the square root of 2 has a place right there. And pi has a place right there on the number line, on the real number line. All those things do, but whenever we start getting into what we call this imaginary category, or the complex realm, we can't graph them on this number line that we're used to. So that's kind of why we call them imaginary numbers. So they're a real concept, but we still call them imaginary. Euler defined this because he thought it was kind of tedious to write the square root of negative 1 all the time. He's just said, hey, I'm going to use this italicized lowercase I to represent this imaginary unit, the square root of negative 1. And don't be confused, his name is said Euler, like the oil you put in your car to keep it lubricated. It's the proper way to say his name. Alright, so let's think about this. If I is equal to the square root of negative 1, that means I squared would be the square root of negative 1 times the square root of negative 1. That would be like saying negative 1 squared, square rooted. Those are opposite operations. So this comes out to be negative 1. So if you want to put a star next to that, I squared is equal to negative 1. Talking about I cubed, that's going to be square root of negative 1 times the square root of negative 1 times the square root of negative 1. These two together comes out to be negative 1, so this is going to be negative 1 times, and this is just I, so then this is going to equal to negative I. So I cubed is equal to negative I. And then I to the fourth, negative 1 times. this comes out to be negative 1, and this comes out to be negative 1. So this comes out to be negative 1 times negative 1, which is just 1. So I to the fourth is equal to 1. Then actually, it just starts repeating again. This one is going to be I, and then negative 1, and then negative I, and then 1, etc. as it keeps going on down. Alright, so let's convert these numbers using Euler's formula, or Euler's notation. So this would equal to the square root of negative 1 times 17, which would be the square root of 17 I, and that I is outside the square root. This one is going to be the square root of negative 1 times the square root of 9, which would be 3I. This one is going to be the square root of negative 15, which is square root of negative 1 times the square root of 15. That's the square root of 15I. This one would be the square root of negative 6, which is the square root of 6 times the square root of negative 1, or the square root of 6I. And this one, it's a little bit trickier, but I think you figure this out. This is going to be this first part would be like saying the square root of 3I. The second part would be like saying the square root of 2I. If we rearrange this, this is going to be square root of 3 times the square root of 2 times I times I. This part is going to be the square root of 6. And I times I is I squared. And remember, I squared is equal to negative 1, so this thing comes out to be negative square root of 6. There's a property in your book that says if m and n are both negative numbers, this comes out to be negative square root of mn if m and n are both less than 0. Okay, now I mentioned this term earlier, complex numbers. Complex numbers are just the set of imaginary numbers, which are numbers that have I in them, like this, and all the real numbers combined together. So it's like a big, massive group that talks about all the numbers we've ever talked about in the past, and more, the imaginary numbers we just talked about today. So every number that we've talked about thus far is a complex number. And all of them can be written in this form, a plus bi. The a is what we call the real part, the b is what we call the imaginary part. So say 3 plus 2i, or 4 minus I, or the square root of 17 plus the square root of 2i. These are all complex numbers. Now we can also, any real number that we're used to, we can also write as a complex number. So say like the number 7, that's 7 plus 0 i's, right? We could just say that's 7. Or pi would be pi plus 0 i's, etc., etc. So any number that we've learned so far, we can write as a complex number as well. And to add these, don't get all crazy or anything. It's nothing too hard. We just add the real parts and add the imaginary parts. So here's the real part, here's the real part. So 5 minus 2 is 3. Here's an imaginary part, here's an imaginary part. 6 i's plus 3 i's is going to give me plus 9 i's. That would be my answer for that one. This one, same idea here. I'm just going to write this without the parentheses. 4 plus 2i plus 5 minus 4i minus 3 minus 5i, because it's like it distributes into both of those. I'm going to add together all the real parts. So 4 plus 5 is 9 minus 3 is going to give me 6. Add all the imaginary parts. Negative 4 minus 5 is negative 9 plus 2 give me negative 7, so minus 7i. Alright, a couple more. Let's just simplify these using the principles that we've already talked about. Remember, I times I would just be I squared, so this would be 2I squared. Remember, I squared is equal to -1. So really, this piece right here is just going to be -2. Also remember, I cubed is equal to -I. Right here I have 3 of those, so this is going to be -7 times a -I, and then plus 2I, minus 4, minus, this piece right here is going to be the square root of 3I. Okay, let's simplify this piece right here. -2 is going to be plus 7I, plus 2I, minus 4, minus the square root of 3I. So let's get the real parts together. It's going to be -6. Imaginary parts. 7I plus 2I is going to give me plus 9I minus the square root of 3I. And we're going to try to write this in this A plus BI form. So this right here is the A, but notice I have 2 numbers here with the I. So what I'm going to do is I'm going to say -6 plus, I'm going to open parentheses, say 9 minus the square root of 3, and put the I on the outside. Because think about it, if I were to distribute that I back into each of those, I'd end up just like that. And so now this is the A and this is the B. So this would be my simplified answer for that one. One more of these here. Remember, this I cubed is -I, so this is going to come out to be -3I. I squared is -1, so it's going to be -5. Plus 5I, plus 7, plus, if you go back and look, I to the 5th is the same thing as I, so it's going to be 2I. Now let's go through and combine the real parts. -5 plus 7 is going to give me 2. Combine the imaginary parts. -3I plus 5I would be 2I, plus 2 more is going to give me 4I, plus 4I. And this is written in complex form, or complex number form. Alright, your homework is on page 218. You're going to do the practice, which, yes, that's right, I just did them up there. 6 through 11, 16 through 20, and then 2 more of your choice.